some are enzymes, some are transporters, some are like recognition markers, some are linkers where they can hook up with other cells. There's all kind of stuff can kind of go on with them. Again, same thing for transporters, enzymes, this time on the inside, receptors again. And again, the cell recognition, linking up, and then otherwise connecting the membrane to the cytoplasm and the components in the cytoplasm. Now on my sheet right here, I'm just saying for external peripheral, which means that they would be out on this side here facing the environment, receptors. That's a good thing to think about as a function, because in order to interact with stuff, you got to be sticking off on the outside of the membrane. Internal peripheral. So now we're talking about here on the cytoplasm side, something like an enzyme would be a good example of a function there, because sometimes the molecules come from the outside to the inside. They're not compatible with the cytoplasms. You got to change it a little bit. And then for the integral proteins itself, best example of a function are transporters. These are channels or carriers. And we'll talk about those a little bit with the membrane transport. Okay. So that's the basic overview of the membrane. And again, you see the cholesterol kind of wedged in there. Cholesterol basically stabilizes the membrane at room temperature. Kind of like prevents too much fluidity, but yet allows enough fluidity. Otherwise, kind of maintains fluidity when it gets lower temperature. Don't let it get too thick and slow. And if it gets too hot, it reduces the fluidity, right? So it just kind of stabilizes the membrane. All right, and then the last thing I will say about the membrane structure and membrane function is that there are four basic things that kind of come into play when we talk about moving a substance from like the outside of the cell to the inside through the membrane, or inside to outside, right, either direction. The first one is always the size. And so things that are super little are probably going to move a little easier through the membrane than things that are much bigger. Okay? Another important factor is how similar to the phospholipid part of the membrane is a molecule. Is the molecule. Since the bulk of the membrane is actually composed of phospholipid, a molecule that's lipid soluble means that it would dissolve, it'll just kind of pass through the membrane with no trouble. Anyway, something like oxygen and carbon dioxide would be an example there. Charges on the molecule. So like with sodium, remember it's got a positive charge. So that means it's going to be attracted to kind of a negatively charged surface. Chloride has, the negative charge is a positive charge, you know what I'm saying, right? So again, charges opposite attract. And then the other thing that comes into play are just these, again, transporters. So carriers, channels, things like that will then contribute to the movement of the molecule. And those are going to involve these proteins. All right, well, anyway, that's the basic overview for the membrane structure. Everybody follow that okay?